Okay, we're going to look at how to do drawings using the concave mirror. The first thing we have to do is see that this is in fact the center. I can convince you it's the center of the drawing by going like this, and you can clearly see it's intersecting the rim at 90 degrees. So to find the focus, we have to go halfway between the center and the vertex of the mirror. Well, it's 7 units from here to here. So 3.5 is the center. 1, 2, 3.5 is midway between the center of curvature and the vertex of the mirror. So what we have here now, the vertex is there. Here's the center of curvature, and here's the focus. I wrote them in real pale, and I'm going to get rid of them again because they'll block our view. Now we're going to put a pretend object on. We're going to go way out here, really far out, and we're going to put on a pretend object exactly 2 cells high. This is really important. I've provided the grid on this to make your job a lot easier when it comes to doing the ray tracing. Now the first ray trace is the simplest one of all. If we go through the center on our way to the mirror, that strikes the mirror surface at exactly 90 degrees. So the beam going in, like that, will hit the mirror at 90 and bounce straight back where it came from and graze your head on the way by. That's the easy one. The next one is the ray that goes in parallel, and the grid lines come in really handy. You've got to really make sure you've gone in parallel. And that one will bounce off through the focus and head out this way. Okay? Now we choose a third beam to do the reverse. There's really only two rules here. In through C, out through C, and a parallel path will turn to a path through the focus, and so will the backwards path. So I'm going to choose another color here, and now I'm going to send a third beam right in through the focus. And if it goes in through the focus, it must leave parallel like that. You must make sure it's parallel or it won't work. So what have we got here? We have 3 outgoing beams. They started at this point and they begin to scatter in reality. But at any point did these beams find each other again? Did they come together again? Well, let's see. This one went this way, this one went that way, and this one went this way. Look at right here. They rejoined at this spot. So all the light from the tip that was scattering in reality got briefly put back together right here before they took off again. So that is where our image is. We have a clean image of the arrowhead being created right there. And if we did this for the entire body of the arrow over and over again, this pattern would repeat all the way up the body of this. But this is all we need. When you hold a spoon really far away from your face and look at the bowl side of the spoon, you will see a tiny upside down version of yourself in there. And so at this point, we want to describe the characteristics of this image. And this is where salt comes in. So step 1, the size. The object, the real object is black, turns to the green one. It clearly became smaller than it was. The light started above the axis and it flipped. Your image in a spoon is inverted. Now, the object was located way beyond the center of curvature, very far away from the mirror. But the image appeared between the 2 points. So we would say it was found between C and F. Okay? Now, this image is called real because the beams of light really did come together there. And we'll see that this makes it a projectable image. The other thing about a real image, your brain insists it's coming right out at you. You'll actually back away from it if you don't stop yourself. So this is the first ray tracing when an object is very far away from the mirror. So we would say object beyond, we often use that. C will make a smaller inverted image that's between the center and the focus, and it is a real image.